Hello, welcome back. Let's go ahead and jump right into today's problem. We're looking at LeetCode problem 206, reversing a linked list. So the description says, given the head of a singly linked list, we want to reverse the list and return the reversed list. So being given the head of a singly linked list means that they're giving us this first node, and for every node in this list, we need to reverse this pointer so that instead of node 1 pointing to node 2, we need node 2 to point to node 1 and node 3 to point to node 2, etc. So how can we think about this? Well, first off, it being a singly linked list means that when we're at node 2, we currently have no idea about node 1. So anything that needs to change between node 1 and node 2 is going to need to happen while we're at node 1. The other way to think about this that we need to keep in mind is that once this connection is broken, we have no concept of the rest of the list. So as soon as we replace this pointer is what keeps node 1 connected to everything else. So we need to maintain our current node and the rest of the list to make sure we don't get separated from everything. So let's go ahead and start thinking about all the pieces of this. First off, let's think about edge cases. So say we're given a list that has 0 nodes. So not only does head not have a next node, but head doesn't even exist. What are we supposed to do there? Well, it says in our examples that if we're given a head that's empty, we want to just return empty. And if we think about this with another edge case, we can recognize that having a head that's just a single node here is actually already reversed because there's no pointers to replace. So that means that if we have a head that has 1 or 0 nodes, we're actually already done. So we can say something along the lines of if not head, which just means if this does not actually have a value, or if not head.next, that just means that the next value isn't available. So we only have 0 or 1 nodes. We can just return the head exactly as it was given to us. So this handles our edge cases of 0 or 1 nodes. Everything else should function the same way every time. So thinking about this, starting at node 1, we know that we're going to need to keep track of the rest of the list if we're going to be breaking this pointer and replacing it. And we also need to keep track of the node prior to us. So say we're at node 2, we want to be able to take this pointer to node 3 and replace it with a pointer going to node 1. So this would look like this instead, and then this would be gone. So we need to keep track of both our previous node and we need some way to keep track of the next node. So let's go ahead and say something like for this first node, we need a previous that's equal to none because the previous of 1 is actually pointing over this way and there is no node over here. So to start with, our previous node is going to actually be able to none, which is just null for Python. And then our current node is our head, but we already are given that, so we don't need a separate pointer to keep track of our head. And then we can say something along the lines of for every node in our list or while we still have nodes, so while head dot next does not equal none. And we're not checking for when head does not equal none, because if we've moved on to, so if we've already encountered and processed node 5, we don't need to move on to node 6 because there's no more pointers after node 5. So we just need to keep going until we don't have any more pointers between us and the end of the list. So while head.next does not equal none, we need a way to reverse the pointer from our head node to the next node. So we need to set a temporary variable equal to the next node, and then we need to replace our pointer to the next node with the previous node instead. So this means that our pointer to the next node is actually going to be pointing to our previous node now. So we have replaced this pointer right here going from the head to the second node. This has been replaced with a pointer going this way instead. And now we need to move our head pointer and our previous pointer forward to make sure that we don't lose the rest of the list and we process all of the nodes that we have. So we can say the previous node is going to be moved up to what is currently our head value. So over here, our previous was currently right here. We're going to move this up to the head, and then our head value is going to be moved up to the next node, but it's not head.next because we already replaced this pointer. So we need to use our temporary value that we set up here to make sure we don't lose the rest of the list. So this is equal to our temporary value. And now we need to keep going through this until our head.next value doesn't have any more pointers to replace. So that means that we're at this node and we don't have any more pointers to replace. Now, the last tricky part of this is that once we actually get to the point where head.next doesn't have a value, we're not quite done because think about it, if we get to this value, that means that we just got done replacing the pointer between node 3 and node 4. So node 4 now points back to node 3. We would have set that right here. And then we've moved our head to node 5, but we haven't actually replaced this pointer yet. So our whole list is going to be set up properly like this, but we're going to be missing our last pointer between node 4 and node 5. So we actually have to do that manually. So we just replace this pointer going from node 5. We can just say head.next is actually equal to previous, and this pointer going from node 5, this was pointed to none previously because we can think about it over here. Node 5 would have just been pointing this way over here off to a null node, but we've now set that equal to previous, which builds this pointer right here back to the rest of the list that we just made. So once we put in this pointer from head.next to previous, we can just return our head and we're actually done. That's the whole solution. So let's go ahead and get rid of this and see our runtime and make sure that this runs properly. So we'll go ahead and submit this. All right, so as you can see, it works. It has a relatively good runtime, and that's the solution to reversing a linked list. Thank you for watching, and I will see you in the next one.